guys, I hope you're doing great so far. In this video, we will talk about typecasting, and it's one of the essential topic when we're dealing with different types of objects. We will learn what is typecasting, how to use it, and how to apply it effectively. So let's get started. So here we will start with what is typecasting, and we will see one example here just to get a gist of what is typecasting after all. Then we will see type of casting operators that we use for casting. Then when it comes to class hierarchies, how the typecasting works there, and also how typecasting works with protocols and few takeaways. So I will write here one example. Now in this example, I have let constant value 1. I have given it a string and I have marked it as any type. So any is the type which is the most superior type in the Swift, and we only use it when we are not sure of the value that we are about to receive. And you will not see any type in use when it comes to production level code quite often, because it is not a safe way to mark properties or anything, or basically use any type casually. So I've just marked it as any, and then I'm using value 1 here, and I'm using the operator as question mark. So what I'm doing is casting the value 1 into type string, and this question mark is there because casting may fail, and if it fails it will return us nil, and that's why I'm using if let, that is optional binding, one of the ways of unwrapping an optional. And if it passes, it goes to this block where I'm printing the string value. If it returns nil, then it will go to the else block and it will return the value is not a string. Let's run it, and it gives us the value is string. Hello, welcome to Apple other side. That is, now that we know something about typecasting, let's start with the types of casting operators we have. I will place this here for notes. Starting with is operator, I will write an example here. The use operator is used to check the instance type, and it returns true or false as its result. Now in this example, we have items, which is array of any type values. It has a string, integer, and boolean. Now what I'm doing is just iterating over this one by one, and I'm checking if item is string, then it will return the item is a string, else item is not a string. Let's run it first. I will comment this, and it gives us Swift is a string, 42 is not a string, true is not a string. You can also write here else if item is int, then it should say is integer. Else if item is bool, then it will print item is bool. Else item is of unknown type. Let's run this, and it gives us Swift is a string, 42 is int, true is bool. And this operator is used only to check the type. Now let's take a look at the second one. Now this as question mark operator performs a conditional cast and returns an optional value. If the cast succeeds, you get the value. If it fails, you get nil. I'll write an example for it. Here I'm taking value 2 and casting it to double. If it fails, it will get nil here and it will return It will get to the else block and it will return this value is not double. Let's run this first. I will comment this code and it gives us the value is double 3.141. So to understand it better, the question mark is basically for the casting. We are not sure whether it will be succeeding or it will fail. That's why the question mark is there. And now let's move on to as exclamation mark. Now as exclamation mark operator is forcing a cast if you are pretty sure that the value is going to be of type integer or double, then you can just force cast it using exclamation mark. I will write a separate example for it here. So we have a value 3 constant here of type any. It has a string, and in the next line we are force casting it to string. Because I'm pretty sure that the value is going to be string, I am just forcing it to cast it to string. By chance, if there is not a string and some other value, let's say integer, then this force casting will not succeed, and also it will crash the system. So this is not a good to use when it comes to production level code. We should only use it when we are absolutely sure that the value is going to be of type. I will undo this, and then I'm returning forced cast succeeded and the value. Let's run this. I will comment the previous code, and it says forced cast succeeded typecasting in Swift. If I force cast it to integer, let's see what happens. It will throw an error saying could not cast value of type swift.string to swift.int. So I will undo this. Now let's move on to the types casting with class hierarchy. I will comment this. Typecasting is especially useful when working with class hierarchies. Let's see an example here. Now, before we look at this example, there are two types of typecasting, that is upcasting and downcasting. First, we will look at upcasting. So upcasting is the process of treating subclass instance as the instance of the superclass, and this happens implicitly without you requiring to use any operator like as question mark or as exclamation mark. So this is implicit and we don't have to use any operator when it comes to upcasting. Now let's see this example. We have a class animal which has one stored property and an initializer for it. And we have a class dog which is inheriting animal and it has its own method bark. Now here I've created an instance of dog and a constant dog for it. When we take this instance and give it to the animal let constant here, the animal is of type animal, which is the superclass, and we are passing the instance dog, which is the instance of the subclass. So what we're doing is the instance of the subclass is going to be acting as the instance of the superclass. What it means is you will have access to the properties and method of the superclass only, and you cannot have access to the subclass. That is this method, and if there are properties, other methods, you will not have access to that. And I'm accessing animal.name, which is the property of superclass. Let's run this. I will mention here. Also, I will mention a note here, that is the dog object of type dog is upcast to animal type. Once upcast is done, you can only access properties and methods of animal class, not those specific to dog class. And let's run this example. And then it says the animal's name is Buddy, which is here. Now let's move on to the next, that is downcasting. Now downcasting is just opposite of upcasting. Here we treat the instance of the superclass as the instance of the subclass. Let's see one example. I will mention here. And also, this is not implicit in Swift. We have to use operators for this. So we use as question mark, and also we use as exclamation mark operator to do the downcasting. Now let's see examples when it comes to class hierarchies. It will be more clear. So we have this class hierarchy, animal dog. We will use it. I've created the instance dog and animal, and I gave it as the value to the array of type supertype animal. What it means is this is going to be of type animal, that is superclass, and we have the subclass object listed here. So this subclass objects will be considered as the animal type, that is the superclass, and when we will read it, we will have to downcast it to its own type, which is subclass type. And when we will read it using for each loop, we will iterate through each value or the each instance. Right now it is stored in animals as the super type animal, and we will downcast it from super type to subtype, which is its own type, that is dog. And here we have animal type, which is the super type itself. So let's see how we downcast dog down to the type, that is dog. So when we iterate, we will receive animal, which is the value, and we will use as question mark and then downcast it to its own type, which is dog. Now currently when we just type animal, then it's the type, it's really the dog object, but it is of type animal, that is the super type, and we use the as keyword question mark to downcast it to dog. And then I am printing this is dog name and accessing the property of the superclass, and also the properties and methods of its own class, that is bark, which is here inside the class dog. And if this casting fails, for example for animal, it is of super type and we cannot downcast it to dog, so it will not go into this block and come to else block, where we will print this is not dog, it is an animal type or animal named. Let's run this. I will comment this before we run it, and it gives us this is a dog named Buddy. So for the iteration, while iterating the first value, it says it prints this, and then it goes and calls the method bark, which gives us this print, and that is the first value in the iteration. And for the animal, the second value, it will go to the else block, and this is not a dog, it is an animal and whiskers. And that's it. Let's move on to the next, which is typecasting with protocols. So typecasting also works with protocols. Let's see one example here. First, I will mention a note. Also, you can check if the object conforms to a protocol, or you can cast it to that protocol type. Let's see one example. Now in this example, we have a protocol flyable, which is confirmed by the class bird, but not confirmed by a class fish. It has a method fly, which is implemented by the class bird because it is conforming to the protocol flyable, and fish has its own method swim. I've created an array of type any where I have given the object of both, that is bird and fish. And now we will try to downcast it to the protocol type. So I am iterating over it for creature in creatures, creature as question mark flyable. So if it fails, it will return nil. So I have to handle it. So I'm using optional binding unwrapping method of optionals, that is if let. If it succeeds, I will have the object here and I will call the fly method. And if it fails, which in case of fish, it will fail because it is not conforming to the protocol, it will not have the fly method. Bird is conforming to the protocol and also implementing the fly method. So for bird, it will come here and we will call it the fly method. For fish, it will go to else block and will print this creature cannot fly. Let's run this. I will comment this code. And it gives us the bird is flying, this creature cannot fly. So for the first value bird, it checks for it whether it can be downcasted to flyable and it returns true for that, and it is possible. So we get the object here and we will call fly method here, which will print the bird is flying. And for the second, that is fish object, it will print this creature cannot fly. And that's it. I will write here few things to remember. So starting with use is operator, use it to check an instance type. We can use as question mark for safely conditional casting. That is, when you're downcasting, you are not sure if the casting will succeed or not. If it will not, it will return nil. So we use as question mark for that. We use as exclamation for force casting. Now we use it with caution because no production level code actually uses it, because this is not the right way to do any downcasting, because it will actually crash the whole app if the casting fails. So we always go with as question mark whenever possible and avoid as exclamation mark everywhere almost. Upcasting is implicit, so we don't have to use the operators. Downcasting requires the two operators, that is as question mark and as exclamation mark. Because in upcasting it is implicit, we can treat the subclass instance as the superclass. Automatically it's there. When it comes to downcasting, we have to have the superclass instance. To treat it as the subclass instance, we need these two operators. And that's it. I hope you find this video informative. I will connect with you in the next one.